switch here in a second. While I'm plugging in, I'll apologize up front. I've got a chest cold, so if I start hacking up a lung or anything, I apologize. It's all part of the show. It's working. Awesome. So I've already been introduced. My role, I run customer service. I joined Solo about 6 months ago. Before that, I guess relevant to this group is I was at Red Hat. I led the North American solution architects for all of OpenShift, which was Red Hat's Kubernetes. So I dealt with that for a long time. So I've been talking to people and customers around Kubernetes for a very long time, a lot about Istio. And now we'll talk about, I guess with this environment, it's almost sort of the post-Istio world of like, once you have something like Istio or any kind of a service mesh, what are interesting things you can do with it? And that's really what I'm going to talk about today a little bit. Cool. And just in the topic of trying to give away stuff. So Christian Post also works at us. He's a big talker on Istio and generally has been for a couple of years. He's got a book, Istio in Action. We're raffling it if you fill out that survey. Betty decided that the 7th, 34th, and 63rd, I don't know if those were favorite street restaurants or bars, but anyways, if you're those respondents, we can give you a free copy of the book that's coming out. So just a quick thing about Solo and just to put a little bit of context about this. So Solo, I think at various points have been sort of the number 2, number 3 committer to Envoy, which is the underlying data plane for Istio. Have anybody heard of Istio? Okay, everyone. How about Envoy? Okay, pretty much everyone else. Okay, so we've been dealing with that. We've been helping build products like API gateway products that just like a mini control plane on Envoy, kind of dealing with the traffic shifting. Part of it helps a lot of people that are migrating into Kubernetes world from standalone, so we can kind of route traffic around, do things like that. Service mesh, we've actually built some products and have been working with Microsoft around like the service mesh interface. APIs built on a lot of technology that we've built and open sourced out. So it helps manage, we're not a service mesh, but if you have Istio or App Mesh or Console or Linkerd, it can help kind of manage that. And we're actually finding a number of people that actually have 2 or 3 or 4 service meshes deployed within a cluster. So the idea of multi-mesh, I know it's like, why would you ever do that? But people have things like they have a lot of load up on Amazon. App Mesh has got a lot of deep integration with the Amazon infrastructure, but they might have something that also needs Istio. So how do they deal with that? Or they might have multiple clusters with multiple service meshes deployed, and they need to kind of have federated policy management around that. So we also help with that. What this talk's going to be dealing with is once you've got that kind of world, there's all sorts of interesting things. Like if you've got Istio or any kind of a service mesh, I'll talk about service mesh in general, side proxies, suddenly you've got a lot of observability in the network because of all the sidecars. You can do very interesting things with that. And so that can actually help you a lot with making your larger scale microservice environments more resilient. And that's really what I'm going to kind of talk about today. So really kind of dealing with the problem of when you've got a microservice environment. So now I've taken my nice, happy, monolithic app, I got a single process, and I've now broken that into tens to hundreds of pieces. It's a little more challenging in terms of how do I have to deal with that? Because you've taken this now and you've taken what could still be a big but simple from a deployment topology perspective app, and now you've turned it into a full-scale distributed application. So now again, you could have lots and lots of things. So when you're trying to actually debug this or understand it, you've got lots of interactions. And again, if people are doing kind of DevOps methodology, each microservice is moving at its own speed. The things that you're connecting to are changing at speeds that maybe you're not aware of. They're making changes. You're not fully aware of what happened there, but you're still dependent on it. So how do you manage a lot of that system? And I love this quote from Leslie Lamport, who I actually believe went to high school in the Bronx down here, though he went up to college up in Boston. But he talks about, a distributed system is one that prevents it from working because some machine that you don't even know about has failed. And that's basically what a distributed application environment is that something is broken, you just don't know what in that application. And so how do you start kind of understanding what has broken and how to make your system kind of handle that in a better way? And that's really kind of what we're talking about with chaos engineering. And so this is, from a larger scale perspective, the idea of, when you get to large scale environments like Netflix and some of these pictures are actually old. Like Netflix really kind of coined the terms of like chaos engineering back from 2010 when they created things like Chaos Monkey. Who's heard of Chaos Monkey? That's been talked about a lot. Yeah, so they were seeing the case that random services would disappear. They had to make their system deal with it, so they built an application to go randomly turn off services. Then they built Chaos Kong, which would randomly turn off regions. It would simulate entire region failures. So why would people do that? Well, if you look at these pictures, and I know these have been talked about a lot, but the interaction connective graph between any service and any other service is mind-blowing. There's no way that any person could know, what services you're talking to and how it's interacting. And that's kind of what I mean by the scale of this problem. And I, maybe to inject a little humor, now we've taken our monoliths and have turned it into a murder mystery. Who did it? What broke? I don't know. So it kind of becomes a fun problem. Except when you're debugging it at 2 in the morning on Saturday, it's not so fun. The other part of this challenge is a lot of our tooling has not caught up to this. So we have a lot of great, as computer scientists and engineers, we have a lot of great tooling that can deal with single process debugging. We can understand that stack, we can debug into that, or we have language specific libraries. Again, Netflix did a lot of this, but then Go's got like micro and others. So there's language specific libraries that can help with, service discovery, retry logic, like Hystrix in terms of like circuit breaking. That's great. But again, what happens if I've got some stuff in Go and some stuff in JavaScript or TypeScript? And okay, so I introduce some language specific libraries to help with retrying stuff. Well, now you're debugging the fact that those libraries do it slightly differently. They circuit break slightly. Who's dealt with that problem? I know I've hit that a few people. So you know what I'm talking about. Like the tools are a problem, the language specific stuff. And then, code modification. If you're changing this, if you're changing your code to deal with the fact that something that somebody else just changed is broken. Again, if you're trying to deploy quickly, you're never going to get in front of this. So it's a problem. It's okay. So I've now made everyone depressed. There's no solution. We might as well just start drinking more beer. Or, there's ways to deal with this. So I'm going to use the analogy. I don't have enough time to kind of talk about chaos engineering in a lot of detail, but I'll use the analogy of sort of vaccinations. So if you think about a vaccination, the idea is that I am intentionally injecting a little bit of a virus into a person, a production system, my production system, right? This is me. I'm going to inject it in with the idea that my body's going to generate antibodies to help me fight that off when a real virus kind of, when it hits me, it is a real virus, but if I get hit in a higher dose, in a higher quantity, so that I can make me, Scott, the production system, more resilient to it. So I'm going to intentionally inject a failure, a virus, into a production system to help make it stronger. And that's really the core of what chaos engineering is. And that's what we're going to take to our distributed application, is we need to, in production, intentionally inject small faults so that we can see how the system behaves. And does it degrade gracefully? If I lose a backend system, that depends. Like, I can't get whatever capability is, but is it going to take down the whole system? That would be bad. So how do I kind of manage that? So it's the idea of intentionally breaking it. And, in short, I'll give you, there's a few principles. Netflix has a nice little short O'Reilly book talks about chaos engineering. There's a bunch out there. But kind of two principles I want to leave you with, and I'll talk about is one, the idea you want to automate these experiments in production. It's great. You should do all of your testing that you do in normal system. You should do all your staging. But again, like those graphs showed, you don't know until you get the system into production what the interactions are with all of those other systems. It's only going to happen in production. So you need to get systems and a culture where you're actually going to do testing of these kind of failure scenarios in production and kind of automating that and continuous running it. The second thing you really need to think about is how to kind of minimize the blast radius. So if you interject a fault in your system and it fails, okay, yay, our experiment succeeded, it failed. You don't want it to take the whole application down. You want to kind of have it in a controlled way so that you can experiment. Now, I'll segue for a second. Who's seen the documentary like Chernobyl? That's out now. I'll use a current topic. I'll move away from my vaccination thing. So recent analysis on Chernobyl has actually proved that the real source of the failure, now it was the steam pipes burst because they had a coolant failure. It was actually they were running experiments to increase the power loads. When they were doing that, automated systems were fighting against them, starting to put the control rods in place. So they were trying to increase the power loads. It was triggering automated systems to bring it back down. So they had this sort of fight going on in their systems that weren't communicating. And a third party saw these behaviors, said, oh, something's going really bad in our nuclear reactor, and triggered an entire shutdown, which caused the cooling system to fail. And we all know what happened from there. So this is a horrible example of bad blast radius control. You know, an experiment went bad and something horrible happened. So when you're thinking about chaos engineering, one, you want to think about failure scenarios either you've seen in the past or experiments. You want to say, like, how is my system going to handle these failures? And two, make sure when you do the experiments, it's not going to take down. Hopefully no one here is doing nuclear engineering and running a plant. Please, if you do, don't do that. But, you know, if you're going to do it, make sure you don't take down your whole application. So make sure that your tests have ways that you can kind of control that. Very important. The other thing I'll talk about, kind of bringing it back to, like, how does service mesh fit into all of this? Because I kind of introduced that idea that, you know, this is sort of the post service mesh world. You can do these interesting things. So service meshes, in short, again, I'm not going to do a whole talk. I would love to talk about it. I know there's a social hour. I'd love to talk about service meshes. What the idea with, like, you know, Envoy in particular is a core technology, is a data plane. It basically took a lot of that retry logic, circuit breaking, rate limiting, and moved it effectively to the networking layer. I'll call it the application networking tier, but it basically moved it outside of your code. So all of that kind of common language, Netflix OSS, micro, others, moved it outside. This allowed you to deal with any language you could deal with it. It's just interacting at the network tier at this point. And so it allowed us to have that. It also gave us a lot of visibility in terms of how the network, you know, who's talking to who. So this is kind of how service meshes it. It also, because it's managing, it's proxying all of the network to network communication, it also allows you to do things like injecting faults. Because I can now, since I'm proxying the service you're calling, I can say, hey, that service actually failed. I can inject faults. I can also inject latency. So I can make those connections. So I can now simulate failures. Actually, I'm actually really introducing failures in your network without tampering with the backend service itself, because I'm catching it at the network level. So it's an interesting, service meshes enable, among many things, but relative to chaos engineering, it allows you to do some very interesting things around that. And again, you know, kind of the opposite of a lot of this, it's language neutral because it's built in at the network tier. You don't have to make code changes around it because it's all there. And because of, like, the idea of sidecar proxying that a lot of the service meshes like AppMesh and Istio have all, and Linkerd are all kind of bringing in, you know, I can put a policy so that anything I deploy into any kind of a Kubernetes environment is going to have one of these. So it just kind of comes along for the ride. I don't have to think about it as a service developer myself. All kind of good stuff. So Gloo Shot is an open source project, so anybody can try it. It's up at glooshot.solo.io. Don't try it now because I need the network for a second, but then you can try it in a few minutes. So this allows you to kind of do those controlled experiments. So it assumes that there's a service mesh in place that it can take advantage. If it's using the new service mesh interface, standard APIs that we've kind of, that abstraction we help pioneer, but that's there, so we can kind of work with any of the meshes, any ones that are doing traffic shifting, any of them that have observability capabilities we can deal with. And so we can run these. And you can set what I'll call sort of stop triggers, so that you can say, if something, here's a trigger that if the network, if something is bad happening in your application, stop the experiment in an automated way. So you can define metrics against Prometheus so that you can say, hey, if my application really starts going really bad, stop. Stop whatever thing I had, whatever faults I injected. So hopefully your system will kind of recover back from that. And that's kind of where we're at this point. And this is part of a set of open source projects that we've done, again, to kind of give you a sense of it. But, we've got Gloo Shot, then Loop is starting to, because again, we've got observability in the network. If any request, if a set of services are going through, if they're starting to return failure codes, what Loop will do is it'll actually capture the entire call chain. So it'll know how the request flowed through all of the different microservices. It can capture all of the headers and bodies of the messages. So it can save any failures. If things work, it just throws away the data. But if something went bad, it can save it, which can allow you to then kind of debug that. Again, relevant to if you're doing chaos experiments, something bad happens, you can capture what went bad and then replay that. Hopefully not, you're not going to do debugging in production, because setting a breakpoint in your production system, probably a bad idea. But then you can bring it back to staging and actually replay it with the real data and try and debug that. And then we've also built Squash, was something we built when we were doing a lot of work around Envoy, as you're deploying it in Docker containers or Kubernetes containers. Debugging into remote containers is hard, so we actually built Squash to help us debug it, and then we've released that out to open source so other people can play with it. So it's a tool that can allow you to do debugging into Kubernetes and other environments. Okay, that's all great. Let me show you Gloo Shot, if the demo gods are going to be happy to me, which they may or may not be. So what I'm going to do, up in the doc in GlooShot.solo.io, I'm sorry, I've got limited screen real estate, but over on the left, there's a tutorial. So I've kind of preloaded the beginning parts of the tutorial, which is, you know, like deploying the products, deploying Istio. In this case, it's all running on Minikube in my environment, deploying the book info app, which is sort of the canonic sample app for Istio. So I've deployed all of that onto Minikube running on my laptop. And then we're going to actually run a couple of experiments on that, and you can see that. Again, all of this is documented. So if you do want to try it yourself, you can go download this, play with it yourself, have fun. We love feedback. There's a public Slack channel all of our engineers listen to. So if everything works, great. If you find things that don't work, let us know. We'll try and fix it. So we love feedback on that front. The other things I've got going over here, so the classic book info app, yay, it's running. I've also got a Prometheus console up here, so we can kind of see some of that. And then I've got my command line hiding. Oh, and I'll hide that at the bottom. So, and a couple of things just to give a little bit of context. So, again, in that small picture on the diagram, so the book info app actually has a product page. It calls out to a set of review services, and then that calls a rating service on the back end. So, you know, the review service is going to say, you know, whether people liked it or not, and the rating service is actually going to say how many stars it get. So we introduced a fourth. I got to update the picture, but we introduced a fourth review service that we're going to build a test against. To see if it fails gracefully or not. We're going to actually test, we're going to introduce faults on the rating service, sort of the back end, and we're going to see how the review services behave in the case of a back end fault. Okay? Cool. So let me, again, for a little bit of context, and I'll also test to make sure my system's running. So in Prometheus, this little Prometheus graph is our exit failure case. So we're basically saying, hey, if we're seeing too many 500s out of the review service, so the thing in the middle, we're seeing too many of those, stop the experiment. You know, within a minute, sort of, if we get too many, it's like, stop. You know, things have gone really bad, stop. You know, we don't want that. So we're going to intentionally fail the back end, but this is our failure case here. And then everything we do, the solo projects that are dealt out there, you know, we're doing things with using custom resources. So we'll build those out, and those help control the deployed services inside of Kubernetes. So I'm going to try and even be brave. I'm going to actually use our live doc. I'm going to copy the command. I'm going to paste it into command line. It's going to work. So now I've got an experiment running, and I probably should have explained that. So I'll explain it while I'm running the test. So what this experiment is doing is I define the failure case, and then I defined, hey, on the bookend service, introduce 500s 100% of the time. So I'm basically completely failing the release service. And we're seeing up in the book info, when I reviewed it, it actually failed both the review and the rating. So not the stars went away, and actually the text for the review went away as well. So it's a complete, like, catastrophic failure. The review service just dropped. Very bad. I don't want that. But I clicked and it came back pretty quick. If I had gone quick, within a few seconds, it actually brought it back. So it ended up deciding, whoops, and let me show you on Prometheus. So if I go update my graph, we suddenly see This is the graph of 500s coming out of their view. We see the spike. Our test, that test scenario, that little graph, you know, this Prometheus queries over here said, hey, if we see lots of 500s, whoop, experiment's gone bad, stop. You know, went too bad. So we introduced too much chaos, slow down. So that's what happened. So we see Prometheus spiked. And then let's go look at the results from the experiment itself. So we actually, oops, don't jump around on me. Is a live demo, so hopefully all kinds of crazy things could happen. So down here in the text, hopefully it's big enough you can see. Again, you can try yourself. So it stores the results actually in the experiment object itself. And then we see in this case, and hopefully you probably can't see, it's a little too small, but this thing is actually saying that it's a failure report. So it's saying that this experiment stopped because of that experiment failure scenario was triggered. So it's telling us, here's the reason why we tried the experiment. It's actually going to keep all the results, the time snapshots of what happened. But in this case, it said, hey, we triggered the experiment stop scenario. And it's going to tell us that. We're like, okay, great. You know, that. And there's actually report objects in this case, because it stopped quick. We're not going to see a lot, but I'll just show you real quick. Oops. I'll show you the contents. It might be more interesting. There's a report object. So there's the experiment itself that has some status, and then there's a report. In this case, it stopped pretty quick, but it would actually keep time snapshots of all of the data so that you can pull it out of the custom resource and do it. Obviously, all the data itself is also in Prometheus, so you can use that to do some analysis around, okay, I saw failures. What happened? Okay. So that was a case of, yep. I'm sorry? Yep. Yes. Yeah, so it'll keep, I mean, obviously Prometheus is running in your app, and then for the experiment, it'll keep the stats about what you told it to kind of watch, what trigger cases, so it'll keep that information as well. If you wanted things like the full call graph and stuff, that's why we're starting to build projects like Loop and other things to actually kind of capture the request headers and bodies and the full call graph, because that's outside of the scope of what Gloo Shot's doing, but we're trying to build some other things because we think it would be useful to have that kind of information. Okay, yep. And it's sort of, this was all around, you know, tracking things.
We have a catch box here. If you want to ask a question, just ask for the catch box so we don't have to repeat the question. There's a mic there.
Sorry. Thank you. No, perfect. Cool. So, actually, good questions.
Thank you.
I've introduced that up front. So we got swag. So now I'm going to try and see if I get some more interactive. I only got one more experiment I'm going to run. So, now people are going like, hey, I want to ask questions too. I'll be around later, so I'll give out more stuff later. So, so let me go rerun the experiment. So we're going to go. We realized, hey, we revved the review service. We tried our experiment. We realized it does not fail gracefully at all based on rankings. Bad. So let's roll back. Now, in this case, all of the review services are actually already deployed. Like that's part of the book info app. That's part of the classic examples that is showing off Istio traffic shifting, right? You know, there's multiple review services and we can run different loads at it. So we're going to go back and update that. This little snippet over here, we're actually using Super Glue, which is that sort of management. That's the implementation of the service mesh interface. So it's going to allow us to provide routing rules. So we can say, hey, for any service mesh that's under management, we can change the routing rules and it's going to go translate it. So in this case, I'm going to introduce a change and say, hey, go to routing to review version 3, you know, sort of and go back to that. And now we're going to rerun an experiment and see if that one fails more gracefully. So let me stop jumping. Let me run another experiment. So again, this other experiment, same failure scenario. We're still looking, you know, introducing a ratings of 500. So we're still going to fail the backend rating service 100% of the time. Again, we could make it an intermittent failure. In this case, we're making it a catastrophic failure. And then we're going to run this experiment for 30 seconds. The reason I'm saying this is I'm hoping this experiment's going to go a little better. while we're doing this. So now I've got the experiment running. So now if I refresh the page, we see up on the screen, the reviews are still coming up. You know, comedy of errors in extremely entertaining place. The reviews are still coming, but the stars aren't. And we're actually seeing a graceful fail because it's actually saying, hey, rating service is unavailable. So this is a graceful kind of circuit breaking scenario. Backend service is completely failed, rating service, but we're still providing, you know, the review service is still working. It hasn't failed entirely. That's a good thing. You know, we've kind of gracefully failed our application. This is exactly the kinds of things we want to test in terms of the interactions between it. How is it going to deal with, in this case, I'm doing 500, I'm completely failing it, but I could be doing, what if I introduced your high latency? What if I introduced a 10% failure of the ratings? How is it going to behave? Don't know. So this is exactly what you're going to do chaos engineering in production to kind of test what those interaction patterns are going to be. So 30 seconds has gone by. Our test has stopped. You know, we're back to the little stars. So let's go look and see what, from a different experiment, what the reviews are. So in this case, the results here is the experiment succeeded, which means it ran the full 30 seconds. And if we go look at Prometheus, go re-execute the queries, we see, you know, here now the number of, you can't really see it, but that it's a flat line, it's 0. So we saw no 500s out of the reviews. Good. So we didn't trigger any failures. So the experiment in that sense is considered a success when we didn't trigger the experiment failure scenario. But now we've got data around how it behaved. And we also now have insight around the fact that, you know, how the review service kind of, in this case, gracefully degraded when the rating service went away. So it kind of gave us some insight around how it's going to behave in a production environment. So with that, let me, I guess I'll stop. I mean, I know I'm kind of basically out of time. So again, everything I showed you, you can download it, GlooShot.solo.io. You can download this, try it all yourself. It's documented in that. There's a tutorial link. You can try it all yourself in your instance. It works in all the different clouds and stuff. Give it a try. There is that raffle. If you're one of those weird numbers, you know, we'll give you one of Christian's books as well, and be happy to talk to people afterwards about anything. So thank you very much. Yeah, absolutely.
All right. Any questions? We'll take two. Anybody?
Thanks. Hey, I couldn't really see the screen too well, but it looks like you made your own type, right? It looked like you had your own Kubernetes custom resource, right?
So those things I was showing, which you couldn't really read on the screen, those are, we've got a bunch of custom resource definitions. So in the case of Gloo Shot, we've defined an experiment custom resource and a report custom resource.
Okay, all right, I got it.
So that way you can configure. So what I was showing is like when you're configuring the experiment, you're just defining variables in a custom resource. So
right.
it's all just YAML files.
You install like a custom controller into
that's exactly right. So Gloo Shot is a custom is an operator. If you're kind of using like the Core OS thing, basically an operator that's going to watch those custom resources and then make changes based on that.
Okay, great, thank you.
Cool. Perfect. This seems completely at a network level. Have you thought about doing other things like mangling response JSON to see how upstream microservices respond, or I don't know, injecting some data faults?
So you're talking about like corrupt message kind of scenarios. Yeah, in theory, we could do that. At this point, we were just looking at it from just introducing network failures, because that's a very common scenario. I think data corruption, we could look at some of that. Some of that starts to fall into kind of functional testing as well, because it's sort of how are you going to deal with that? So I get, you know, that is a scenario you need to deal with. So it's certainly possible. Envoy allows you to deal with request and response transformations, you know, as part of the filter chain. So it's something you could absolutely introduce. So we love contributions as well. So if you want to go contribute, you know, we'd love to, you know, open a PR, you know. Cool. Thank you very much.
Thank you, Scott.